Hello, these are, your video notes for 5.4, and we're talking about graphs of the sine and cosine functions. And so we're going to use our unit circle to graph sine on a Cartesian plane and cosine on a Cartesian plane. We can do this for all 6 functions, right? We talked about tangent as well. We talked about cosecant, secant, cotangent. We are simply focusing on sine and cosine in this class. So the inputs of sine and cosine function represent, well, we have to just ask ourselves, what are we inputting into our function? So here is our function. This is one way to write it. Another way, if I wanted to use function notation, it looks like this. Those mean the same thing. Well, our input, just here, it's clear what our input is, and it's actually an angle. And then we talked about our outputs are our ratio of side lengths. So for sine, it's opposite over hypotenuse. So I'm going to go over here, and I'm going to look at my unit circle that's provided to the right, and just choose angles. And I'm going to make one full revolution around this circle. I could go on forever, but we talked about sine being periodic, and we talked about sine's period is 2 pi. So it's just going to repeat itself. So I only need to look at this circle going around once. You can do either direction. I'm going to choose to go positive. So I'm going to choose to put in angle 0. I'm really working on my handwriting, I promise. 0. I'm going to choose pi over 4. I'm going to choose pi over 2. I'm going to choose 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and a full revolution at 2 pi. You can choose any angle you want, right? I could have even chosen angles between 0 and pi over 6. So in other words, angles that are smaller than 30 degrees. But they're not on my unit circle, so it's going to be really hard for me to plot. Those values do exist. It's just very hard to find the exact value, like we can using special right triangles. So when I put in 0, my sine value gives me 0. I put in pi over 4, I get out root 2 over 2. I put in pi over 2, I get out 1. 3 pi over 4, root 2 over 2. Pi, 0. 5 pi over 4, negative root 2 over 2. 3 pi over 2, negative 1. And then I'm back at 2 pi. So it looks like I get 0 again. Well, these are actually coordinates. My input is 0. My output is 0. My input here is pi over 4. My output is root 2 over 2. Okay, so I'm going to write all of these as a coordinate. Okay, pi 0. Again, for whatever reason, it is a challenge to write on this iPad, so I'm working on it. And 2 pi 0. So what I'm going to do is I'm going to take these coordinates and I'm going to plot it on this Cartesian plane that's provided. So I gave you a specific scale. When we get further into this lesson, you will choose your own scale. So I'm going to plot my points, some pink. So it looks like 0, 0 is a coordinate. Plot that guy. And then I have pi over 4. So you have to pay attention to your scale. I gave you 1, 2, 3, 4 tick marks represent pi over 2. So that means halfway between that, this is where pi over 4 is. Hopefully that makes sense. So I have pi over 4 is root 2 over 2. Yikes, a little challenging to plot. But if you put root 2 over 2 in your calculator and calculate it, it's roughly 0.7, so I'm just approximating. So if this is 0.5 here, then this would have to be 0.75. So it's a little bit under right there. A complete approximation. Pi over 2 coordinate is pi over 2, 1. Then I go to 3 pi over 4, again would be halfway through this, is root 2 over 2, so I'm back here. Pi 0, it's a nice one. 5 pi over 4 would be halfway between here, so that would be negative root 2 over 2, so I'm just a little bit like right here. 3 pi over 2 gives me negative 1. We did not plot, 7 pi over 4 just because I ran out of space on my chart. But if we wanted to plot it, it would be right here. And then 2 pi gives me 0. So what you have here, if I connect these points, so remember, all these values exist between, these values that I ended up choosing. I just randomly chose those. But, pi over 6 puts out something. Even pi over 7 puts out something. So this is a continuous function. So we have a sine wave that looks like so. Now, this continues. We talked about it being periodic. So you want to make sure you put arrows on your graph. That is very, very important. And this would continue on, right? Because all you're doing is you just keep going around the circle. Or it even continues on here because you're just going to switch direction. So this is your graph when you have sine of theta. So going here, I have it plotted for you already. So plotting pi over 4 was somewhat challenging because I had to approximate it. I would always choose these key values, 0, 0, let me get another color for us. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. Because look how easy that is to plot, and all those angles exist in between, and so that's why you connect these points. So what happens here is we're looking at this sine wave, the sine function. Well, there looks like there's a clear middle of this graph. I could cut this graph in half since there is a maximum and a minimum. That is known as your midline. So it's the horizontal line midway between the function's minimum, which is this guy, and the function's maximum. So for this one, where I drew the line, if we remember back in the day to equations of horizontal lines, that is y equals 0. And then another definition is the amplitude of a function. And the amplitude of your sine function is the height, okay? The distance, key thing is distance, so that would be positive, from your midline up to the maximum. So for us, if we go from our midline up, that distance is 1, right? Because we stop at 1 here. So our amplitude is 1. Now again, for amplitude, it's always positive. Always, always, always positive. So we're going to talk about some characteristics of your sine function. Looking at this, your domain, again coming from 111 days, or your previous algebra class, whenever you took it. Your domain are your x values, so this is also known as your inputs. And that we're talking about angles, right? So if we look here, we can put in 0. We put in all these angles up to pi over 2. We put in all these angles. We put in all these angles. I could also go in the negative direction and put in negative angles, right? The fact that this function is continuous, I can put in any single angle I want. And that's why my domain is negative infinity to infinity. Another way to write that is all reals, but at this level, we want to use interval notation. Your range, this is your outputs, so your y values. Well, how low does this graph go? Well, the lowest it goes is -1, and the highest it goes is 1. And it includes those values. There's no open circles. So that's why it goes from -1 to 1. So would this be an odd or even function? Well, you talked about that in respects to algebra, where you put in a negative, does the output get affected for sine? And it did. But if you want to visually see if something's odd or even, if it's even, it would be symmetrical with the y-axis, which this is not. It's not symmetrical with the y-axis. If it's odd, it'd be symmetrical with the origin, which is right here. I'm going to make it big. And this is symmetrical with the origin. So that's why this is odd. What's your amplitude? That's the new definition we just learned. Well, that's the height from your midline up to your maximum. And so that's why my amplitude will be, oh, not that, will be 1. Your period will hopefully, this is making more sense. Your period, remember, is when it starts to repeat itself. So if I just look at this visually, I go up, I'm like on a roller coaster. We go down, we hit the x-axis again, and then what do you know? We start to go up again, and then we're going to come down, and then we're going to go back up. And that happens from here all the way to here. Well, that period length is 2 pi. And then it starts repeating itself again. My midline, that's where we can cut the graph in half, is always an equation. So it's y equals 0. Please don't just tell me 0, because it's a line. So you need an equation for a line. All right, so now we're going to talk about cosine. And then we're going to talk about easy ways to graph these quickly. So we're going to do the same process with cosine. I'm going to go ahead and just choose some random angles. But based on my scale that I gave us, I'm forced to kind of choosing the pi's over 4. So I have 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and a full revolution, 2 pi. Okay, I look at 0, cosine gives me 1. I look at pi over 4, we also get out root 2 over 2. Pi over 2, cosine is 0. 3 pi over 4 is negative root 2 over 2. Pi is negative 1. 5 pi over 4 is negative root 2 over 2. 3 pi over 2 is 0. And 2 pi, we're at 1 again. So I write these as coordinates. I'm just going to do this quickly. I get pi negative 1, 5 pi over 4 negative, oops. 3 pi over 2, 0, and then 2 pi, 1. All right. So hopefully you're feeling better about this, and you can just go ahead and do this on your own if you'd like. But I'm going to keep talking us through it if we need it. I'm going to plot these coordinates. So I have 0, 1. So that starts here. My next coordinate is pi over 4, which is here. Root 2 over 2, so we talked about what that is. That's approximately here. Pi over 2, 0. 3 pi over 4 negative root 2 over 2. And again, I'm totally approximating that because it's irrational. Pi negative 1. 5 pi over 4 negative root 2 over 2. 3 pi over 2, 0. And then 2 pi 1. And we could have plotted 7 pi over 4, which would be about right here. Oh, no, not there. It would be here, which is like right there. Get rid of that. Oh. Here we go again. Okay. So now I'm going to connect these points. So this was just me showing you where pi over 4 was. Okay, so let's go ahead and graph this guy as an orange. So I'm just connecting all the coordinates. And that is one period of cosine. Because remember, we talked about that cosine also repeats itself every 2 pi units. So if you were to go ahead and plot, if you keep going around that unit circle, this guy would end up just coming back down. And over here, this guy would end up coming back down. Don't forget your arrows, please, because that's telling your reader that this guy goes on and on, right? It doesn't just start at 1 and end at 2 pi. We're just looking at that period, and that's it. So here's more of the graph for cosine. This was if I continued on in this direction, it would go back down there. Oh, I don't want that to be straight. So I just go back down here, and then I continue on, and so forth. So this is known as your cosine function. So for this one, your domain, if you take a look at this graph, well, again, you can put in all angles that you would like. So it's negative infinity to infinity. My range, my y values, well, the lowest it goes is negative 1, and the highest it goes is 1. Odd or even? Well, remember, it's even if it's symmetrical with the y-axis, and this is. I could fold this graph on top of itself over the y-axis, so this is even. Our period, just even looking here, if it didn't make sense when we talked about it on the unit circle, we start here, and you can start anywhere you want, and then you measure the length until it starts repeating itself. So at 2 pi, we're going to start going down and then back up again. So that's why it's 2 pi. My amplitude, well, remember from my midline, so maybe I want to do my midline first. You cut it in half. It won't always be here, but for this one it is. And that equation is y equals 0. And my amplitude, remember, is the height from my midline to my maximum, so it's 1. All right, so the last little part of this video, you have some blank space here on your notes. I just want us to get a better handle on graphing these quickly, because you don't have to graph all of these coordinates. That was for us to understand where the graph is coming from. So one thing we know from just going over this is we know what the sine graph looks like, and we know what the cosine graph looks like. And so I'm going to give myself a Cartesian plane. Label it, please. So my inputs for this is theta. So I'm going to label my x-axis theta, since that's what my input is. It doesn't say sine of x, so it's not an x-axis. And then this is my output. I'm going to do the same over here. All right. Now for you, when you start graphing these on your own, you're going to come up with your own scale, because it's going to make your life much easier than me giving you the scale. So the key thing when you graph these is you have to let me know what scale you're working on, because you could use different scales. It's whatever your little heart desires. But I know some really nice points for sine, so I'm just going to focus my energy on sine for right now. Some really nice coordinates for sine is this one, this one, this one, this one, and this one. Again, I have coordinates for every single angle, but plotting these values is so much easier than trying to approximate where root 2 over 2 is or where root 3 over 2 is. So I'm just going to focus my energy on 1, 2, 3, 4, 5 coordinates. So let me go back here. All right, so I start at 0, 0, and I go 1, 2, 3, 4. My fourth coordinate is going to be the period, which is 2 pi. So I have a scale there, which is great. So now I could go in the negative direction if I really wanted to, which is what you should do, because we always plot, always graph at least 2 periods, because it gives you a better idea of what's happening. Well, I also need a scale for my y-axis. Many of us forget that. Well, remember the highest it went, because of our range, was 1, and the lowest it goes is negative 1. So I have a scale. So if I look back up here, these wonderful nodes, let's see. My very first coordinate is 0, 0, and my last coordinate is 2 pi 0. So I'm just going to plot those. Let's go back here. Let me give myself another color. So I have 0, 0, and 2 pi 0. Now, there's a nice pattern with sine. And if I look back at the graphs, hopefully I'm not making you dizzy doing this. We started here, and we ended here. Halfway between, we hit the axes again, right? Halfway between this was a high point, and halfway between here and here is a low point. That's really nice to know, because that pattern exists no matter what you do to this graph. But we're going to be graphing transformation, so it will shift and such, but that pattern always exists. So between your beginning and your end of your period, you hit the axes again. And then between this point and this point, we hit a high. And between your last 2 points, we hit a low. I could have also just looked at my list of coordinates, and realized, oh, okay, well, if this is 2 pi, that means this has to be pi. And that coordinate was pi 0, yep. If that means this has to be pi over 2, and we know pi over 2 puts out 1. So here is 1 period for sine. Now to go in the other direction, we can look at our unit circle and figure it out. And we could look, okay, well, if I look at negative pi, well, that gives me out 0 for sine. If I look at negative 2 pi, that gives me out 0 for sine. If I look at negative pi over 2, that gives me negative 1. And if I look at 3 pi over 2, that gives me out 1. But I'm not going to have to rely on my unit circle anymore, hopefully, because I just know this is what this wave always looks like. So if I'm here, I have to go down, because otherwise it wouldn't be symmetrical with the origin. And we know that sine has to be odd. Also, another key thing is make sure these, like your peaks and valleys, that they're smooth. This is very important for calculus. Don't make them points. They have to be smooth. All right, let's do cosine. So for this, I know my one full period for cosine is 2 pi. So I always just make that last tick my period. I'm going to go in the other direction. And then we know our highest point for cosine is 1 and negative 1. And so I'm going to go ahead, and again, either you guys can refer to, I just don't want to keep going back and forth, but you can refer to these coordinates, and you can see, well, let me go ahead and erase this stuff. All right, you can see, here's a nice coordinate to plot, here's a nice coordinate to plot, here's a nice one, and here's another nice one, and here's one. So I'm only going to plot those because they're nice and easy to plot. Make it green, make it fun. All right, so if I put in 0, I get out 1 for sine. If I put in pi over 2, I get out 0. If I put out pi, I get negative 1. If I put out 3 pi over 2, I get 0. And 2 pi is 1. So another way we could have done this is we could have known, okay, wait, this guy starts at a high point, and it ends at a high point. And halfway between here is a low point, and then we hit zeros. That will make more sense once we start graphing more. One key thing is to know sine starts at 0, 0, where cosine, oh no, I didn't want to do that, starts at a high point. I'll say that throughout the lesson. All right, so going back here, green, I have a point here. I actually erased and a point here. Okay. I'm going to go ahead and make this wave. Great, it comes back down. But I also know this wave continues in the same pattern on the other side because it's symmetrical with the y. So I know I hit here, I know I hit here, I know I hit here, and I know I hit here. Again, you could just refer to your unit circle if you're not seeing where those values are coming from, but it's nice to know the pattern. So cosine takes on this W look, and where sine starts at your origin, or I should say midline. Okay, that is it for this video.